Okay, so I'm officially live. Good morning, good afternoon, Comer families. So normally Tuesdays would be Tinker, Design, and Engineering, but since you don't have your kit yet, I thought we would do some kitchen science. So do a little science with some things that you might have around the house to make it, readily accessible for people to for students to participate. Now, I had planned to do this originally on my iPhone, but YouTube has all these rules, honey, anyway. So we're doing it with my webcam on my laptop. So hopefully this works out. Y'all let me know if this is not working for you. Okay? All right. I'm going to push this back a little bit so that we our lesson today. So our lesson today, we are going to talk about the concept of density. What is density? Well, you know what? I have a handy dandy definition right here. And I'll write it right here on this board so you can see. I see a certain person is doing something I asked them not to do. They should leave. Take it with you. Take it with you. Take it with you. Now, 3, 2, 1. I'll tell you. Anyway. Okay. So the concept of density, right? So density, had not thought about that. We might have to record these. At any rate, density is the degree of compactness of a substance. So what does that mean? That means how compactness, right? So let me give you an example of something, okay? Here we have a handy dandy roll of paper towels. This paper towel here is not particularly dense, okay? We're talking about compactness, right? Okay. So how would we make this flat paper towel compact? By crumpling it up, okay? All right. Now, it's a lot smaller and it takes up less surface area than it would if it was flat, like it originally was. How could we make this denser? If we add water to it, that will make this way more and it will sink to the bottom. Much like when someone makes a spitball, okay? What do? You tear up the paper, right? You crumble it up, and then you spit it. And it's the water liquid, the saliva in that particular instance, right? That makes it denser, makes it heavier, and allows you to hit your target. Okay? Science. So we're going to do 2 experiments related to density. Okay? One involves a lemon, and the other involves some household liquids that you probably have at your house. So we're going to do experiment number 1. Let me gather my things. Hold on 1 second. Okay, so for this experiment, we need 2 cups of water. You only really need 1 lemon. An orange would work too. But so I'm gonna use 2. Okay. And some salt. Now, I'm noticing that you guys cannot see what I'm doing. I'm gonna try and tilt this down so that you can see what I'm doing here. Weird angle, I know. All right, so we got our 2 cups of water here, okay? And we have our 2 lemons. They're approximately the same size, more or less, okay? All right. And then we have some salt, okay? All right, so in fact, this probably would be better with just the 1 lemon, so I'm gonna take this other one out. So we got the 1 lemon here, okay? And I'm gonna drop it in this glass of water. And when you do this, you want to be careful that you don't put too much water in because the water will be displaced. And what we don't want to do is make a mess. So I'm going to put this water in. Okay. And you see that the lemon is floating in the water, right? Okay. And in fact, I added more water. And the lemon is floating even more than it was when we started. You know what? Sometimes during kitchen science, you gotta switch up. So that's what we're gonna do. Okay. So we're gonna pour the water in the bowl here, like so. All right. And I'm gonna put the lemon. And you can see that the lemon is touching the bottom of the bowl. Okay, you see? We're gonna do it again so you can see. It's just sitting there. It's not floating, anything like that. Okay? All right. So we're gonna do 2 things now. Because what we're trying to do here is get this lemon to float. Okay? Let's see. Now, did adding more water help the situation? Not at all. Not at all. You know what might help? Da, 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 da. So let's try. Okay. Okay. Now we got the salt in there. Should probably stir this with a spoon, but I'm going to stir it with my hand because why not? All right, so we're going to stir the salt in the water, and we're going to see if that affects the ability of this lemon to float. Okay, so the salt has been stirred in. Okay, all right, I'm gonna put the lemon in again, see what happens. Okay, remember the first time it sank right down to the bottom, no problems. Let's see what happens this time around. It's still sinking. You must not have added enough salt. Okay, let's add some more. Okay, let's try it. Let's stir it some more. Okay, let's see what happens now. Let's see, is it floating? Is it floating? Let's hope so. Oh dear, I got water all over the computer. Can't take me anywhere, I tell you. Is it floating? Not yet. Oh man, this requires a lot of salt, guys. More salt than I anticipated. Well, I think it's quite dense. All right, about to run out of salt over here. Let's get some more. More salt. Okay. I'm gonna take our lemon out here. We're gonna add more salt. Ooh, quite a bit. Oh no. All right, we're gonna just all of this salt in the water, like so. And if this isn't enough salt, then gee willikers. Might just have to move on to experiment number 2. Because it's more salt than I anticipated. Next time I will buy a box of salt strictly for this experiment, I tell you. I tell you. Okay. All right, almost. Oh, no. One more. Okay, let's try it again. This is the last go around. Uh-oh. Let me get it out. There it is. Okay, let's see. Uh-oh. Wait a minute. Did it do it this time? It did. Okay. It's a little hard to see because the water is kind of cloudy. But no, got water on the screen here. See, can you see that? The lemon is no longer sitting on the very bottom of the bowl. I added enough salt to make it flow. So the question, and I want you guys to try and do this at home yourself. The question you need to ask yourself is, why did salt water help the lemon float? That's the question we must ask ourselves. It would not float in regular water, but it would float in salt water. Why is that? Okay, so that's experiment number one down. We're going to do our next experiment about density. Hold on 1 second. Let me gather my things. Okay. Okay. Now, I'm going to tell you right now, off the bat, be better with a little bit of food coloring. But I don't have any, so we're going to do it anyway. All right? So, what do we have? We have a clear glass vase. I chose this because I thought it would be easy for you guys to see it. So I picked this as opposed to a regular glass for that reason. Okay? All right. And then we have some liquids that most households will have, I do believe. All right, so we got some rubbing alcohol. We got some oil. We have some honey. You could use syrup or corn syrup, something like that. That would work as well. Got some plain old tap water. And we got some dishwashing liquid. Okay. All right, cool beans. So, first thing you want to do in your glass here is put in your densest liquid substance. Now, of the three things that I showed you, what do you think might be the densest? Want to take a guess? Just take a quick guess. See what you think. Right, it's the honey or the syrup. We're going to add that first. Oh, there we go. We got a layer of honey in that glass. All right. Now we're going to add our next liquid. What liquid do we think is more dense? Is it the rubbing alcohol? Is it the water? Is it the oil? Or is it this dishwasher liquid? What do you think? I'm going to go with the dishwasher. Okay. Obviously, we will not be eating this honey. There's no going back. All right. Now make sure when you pour these things that you pour them in slowly because you don't want it to disrupt the layer above or below. Okay? Okay. We're going to put that to the side. Let's see where we are. Cool. Okay, so I was right about that part. The honey is denser than the dishwasher liquid. You see it's floating right there on top. Okay, let's see what happens next. All right, now we're down to 3 items. We got oil, we got water, we got rubbing alcohol. Which one do we think is denser? I think it's the oil. Let's try it. Let's see. Okay, I'm gonna pour this slowly. Slow, slow, slow. Slow, slow, slow. Okay. We got it. Slow. So now we got a layer of honey, a layer of dishwashing liquid, and a layer of oil. You see? We've all separated out, right? Because each layer is less dense than the one before. Okay, we're down to 2 liquids. Let's see what happens next. Okay. Let's see here. We got, I'm gonna put this to the side. Oh, it looks like I have a visitor. If you have a question, feel free to put it in the chat, visitor. Okay. So we got water, and we got rubbing alcohol. Which one do we think is denser? I think it's the water. So we're gonna pour in the water next. Okay. Now remember, again, this experiment would be a little better with some food coloring, but I don't have any. So we're gonna have to work without it. And when you pour the water in, make sure you pour it in really slowly. Okay. All right, let's see what happens. Well, looks like Miss Fergie made a bit of a mess. But other than that, oh, look at that. The water is floating between the dishwashing liquid soap and the oil. The oil is floating on top of the water. Okay, so water is more dense than oil. Okay, okay. Let's see what happens. Okay, I'm gonna clean up my little mess here. All right, we're down to our last liquid now. Down to our last liquid. Hey, Vince, how you doing? No. On Friday, when the kits are in, I will send you guys a link. Not a link, excuse me. I will send you an email which will tell you where to go get the kits. And then you'll click on YouTube to do classes on Monday and Tuesday of next week, just like you clicked on YouTube to do this class today. Okay, Vincent? Did you get that? If you got that, give me like a thumbs up or say yes or something like that. Okay, back to the experiment. All right. So as I was saying, the oil is floating on top of the water. Veins, Vincent, thank you. So the oil is floating on top of the water, right? Okay, so the last liquid we're down to is rubbing alcohol. You know, this is the stuff mom puts on the cuts after you've scraped your knee up. It stings. You're like, oh no. That's what this is. Okay, so we're going to add some of this. We'll get the top off. Here we go. All right. We'll see what happens next. Do you think this alcohol is going to sit on top of the oil or below the oil like the water? Just think about that. Well, let's see what happens. Okay, I'm going to pour this in slowly. Remember, you have to pour these liquids in slowly. Slow. Okay, let's see. Where are we? Oh, look at that. Can you see it? The alcohol is sitting on top of the oil. Oil is sitting on top of the water. The water is sitting on top of the dishwashing liquid. And the dishwashing liquid is sitting on top of the honey. Okay. It's not going to explode. There's nothing in here to make it explode, Vincent. It is not going to explode, Vincent. Not at all. I am going to put this all down the garbage can, though, because obviously we cannot use any of these things at this point. But the purpose of this experiment was to talk about density. Okay. As I said at the beginning of the video, but nobody was here, but now I have an audience of one. I'll explain that again. It's Vincent's here. So density is the degree of compactness of a substance. In this particular instance, we are talking about the density of liquid, okay? And so compactness refers to mass, which is weight, okay? And how heavy something is, for instance. Sometimes this comes into play when you're swimming, right? Okay, so sometimes some people have a harder time floating than other people. I don't know if you've ever noticed this, if you've taken swim classes or you've been around a bunch of swimmers. But that's because people have different mass and different weights, right? And some body types are denser or more compact than others, okay? And as a result, they have a little trouble, okay? All right, so again, for you to duplicate this experiment at home, I'm gonna write down the things you need right here on this board, Mr. Vincent, so you know, and you can try it again at home with a little supervision from mom, definitely with some supervision from mom, okay? But you need some syrup or honey, will work, either one. When I say syrup, it can be corn syrup, Aunt Jemima syrup, Karo syrup, any kind of syrup will work, okay? Then you want some dish soap. Okay. And you want some water, some sort of oil, some sort of liquid oil, and you want some rubbing. Wait a minute. You're not going to be able to see that. And you'll want some rubbing alcohol. Okay? All right. So you want all of these things. You can even add another liquid to the mix if you wanted to see if it would work. Like, say, I don't know, milk or maybe a little bit of juice. I don't know. Soda might have an interesting density, right? Because it's got all that air pumped into it. So that might be something interesting to try as well. I would definitely get the food coloring done, okay? Because the food coloring will make it a little easier to see where the lines of separation are happening, okay? So I would definitely do that to get some food coloring. So let's add that to our list. And some food coloring. Okay? Okay. All right. Now, I don't think, were you here for the lemon? Let me know if you were here for the lemon experiment. I don't think anybody was here when I was doing it, so I can do it again now that you're here. If you were here for the lemon, say yes. If you weren't, say no. Okay. All right, cool beans. All right. So again, today's lesson is about density. We have already established it's about the weight and compactness of things. Okay. And the example that I used earlier, I said, for instance, when you make a spitball, what do? You take the flat piece of notebook paper, right? Crumple it up, right? And then you put it in your mouth and you either shoot it through a straw or you shoot it directly from your mouth, don't you? Right? Part of what gives you the ability to hit your target is the saliva, because the saliva makes the spitball heavier, which gives it some weight, which allows you to have more direction and give you the ability to hit your target. So that's the science of spitballs. Okay? All right. So here's the lemon experiment. Okay? Now in this instance, let's see here. How should I do this? So I've got a lemon. And I'm going to put this lemon in a big bowl of water. And we're going to see what the density of this lemon is. Now, I already did this experiment once, but I'm not going to tell you what the results are because we're going to do it again right now. So for the lemon experiment, you need a lemon, a lime, or an orange. Any one of those will do, okay? You need a big bowl, okay? If you can use like a see-through or a glass bowl, that's better. And you need some salt. So you need a lemon, a big glass bowl, and some salt. Those are the three things you need, okay? So those aren't real hard to get. So give me 1 second. Let me get some fresh water, okay? So now we got our container. Next, lemon. Okay. Here's our lemon. Here's our container. I'll put it in. Let's see. Okay, I switched to a lemon that was a little bit smaller because this one was like touching the sides and wouldn't go all the way down. Okay. So you want to make sure that the container allows the piece of fruit to go down completely when you do it. Okay. All right. Next step, we're going to add some water. That's all. Okay. So now we've got the lemon in the container and it's floating a little bit. Interesting. I think it's floating because of the size of the container. Because it would not float in this glass bowl. You see the glass bowl? Now this is water and salt in this bowl. And when I had just plain old water in the bowl, the lemon sat on the bottom. It did not float. I added a lot of salt to this to get this lemon to float. All right, let's see what's going on. All right. So we still got some salt in here. It's undissolved, so we're going to stir it in. Whew, it's a lot of stirring with this salt, man. Okay. While we're stirring the salt, I want to share a formula with you. Now, this is a science concept that you are not going to learn till much later. But I want to introduce you to it now. Okay? And the equation is to find density by calculating mass over volume. Okay? All right. Now, to do this, you need to use the metric system, which is not something that we use stateside. But you will start using it once you really get into science. Like you're doing science on a regular basis, and you get to high school, you're doing like biology, all that kind of stuff. You'll be using the metric system all the time then. Okay? All right. So, but the formula is density is equal to mass over volume. Okay? So you can use this formula to find out the density of any object, a lemon, a penny, a cube of sugar, anything You will need some very finely calibrated tools to do that. But the formula is the formula is the formula, and it will work in any instance. Okay? All right. Let me finish stirring in the salt here. We're almost coming to a close, Vincent. We got about, let's see, how much time we got here. Got about 7 more minutes, looks like. All right. I think we got that salt in there good. All right. Now, we're going to take our lemon and we're going to see what happens. This is very interesting. We have to figure out why this. So you see this lemon is sitting flat in this bowl of salt water, but it's floating in this container of plain water. Why is that happening, Vincent? That's the question we must ask ourselves, and the question we will have to solve. I want you to think about that and see if you can come up with an answer for me by next Monday when we have our next science class. Okay? All right. I also want you to try and duplicate one or both of these experiments at home. I would go for the liquid one myself because I think that one will be interesting, more fun than this one. Okay? So, as 2 things I want you to do is figure out why it's not floating in the salt water, but it is floating in the regular water. That's the first question. And then the second one is why do all those liquids have different densities? And what does that say about the matter or state of matter that those liquids are in? So those are some big questions.